Hello viewers, I am Kausalya. Today we are going to see another derivation. The topic is peak time. So what is meant by peak time? So this is a typical response of an underdamped case for a unit step input. So peak time is the maximum value that can be reached by a system. Okay, in a short period of time, the time taken will be less. So the maximum value reached by a system is known as peak value, and the respective time taken to reach the peak value is known as your peak time. Right. So to find the peak value, our first step is we are going to differentiate this time expression and finally equating it to 0. Okay, this is a max step. So this is our expression, that is C of t is equal to 1 minus this e power minus zeta omega nt by root of 1 minus del square into sine omega dt plus theta. Right. The first step is we are going to differentiate this expression. So first step, whenever you differentiate a constant, that will become 0 here. So here it is 0. And when you look at the second term, we are having two terms. So this is your first term and this is your second term. That is, here our first term also contains t and our second term also contains t. So what will be the formula of differentiation then? The formula of differentiation is uv. That is, when you differentiate uv, here we can keep u dash v plus uv dash. This is a basic formula. So here you see, initially we are differentiating, let this term be u and this term be v. Now we are going to differentiate this one. So the thing is, here u dash, that is I am going to differentiate this term. So here this is our expression. So whenever you differentiate an exponential term, it will remain as such. So when you differentiate here we will be having the same expression. You see here minus sign and this expression here. And again, when you differentiate the terms present here, that is e power minus zeta omega nt. That is, when you differentiate minus zeta omega nt, here the value of t becomes 1 and we will be having the remaining terms, that is minus zeta omega n. Right. Dot, here we should keep the v as such. So here this is our v. So this v is written here. Plus uv dash. Now you have to keep this u as such. So this is your u. And you have to differentiate v. So this is your v. So when you differentiate this term, here you will be having cos omega dt plus theta. And again when you differentiate this omega d into t, that this expression becomes omega d. The value of t reduces to 1. Right. And the next thing is, here e power minus zeta omega nt, you see this minus into minus will become plus here. Right. And here this plus into minus becomes minus. Now we are replacing this omega d by omega n. So omega d is nothing but omega n into root of 1 minus zeta square. This is the basic formula we all know. And the next thing, just when you compare these two terms, we have to take the common terms outside. So here this term, you see, this term is present in both the cases. So we are taking this one outside. And here also we are having omega n and here also we are having omega n. So I am taking this omega n also. So the remaining terms will be, when omega n goes out, the remaining terms will be zeta into sine omega dt plus theta minus square root of 1 minus zeta square into this cos into omega dt plus theta. Right. Here the next step is, I am going to replace this zeta and square root of 1 minus zeta square in terms of sine and cos theta. Because from this triangle, we all know this triangle, right? So in this triangle, that is the base is zeta and opposite side is 1 minus zeta square and hypotenuse becomes 1. So from this triangle, I am calculating cos theta and sin theta. So cos theta is nothing but adjacent by hypotenuse. So zeta by 1, that becomes zeta. and sine theta is nothing but opposite by hypotenuse. So root of 1 minus zeta square by 1, that becomes square root of 1 minus zeta square. So in this equation I am replacing this zeta. This zeta can be rewritten as cos theta, and this square root of 1 minus zeta square can be written as sine theta. So here I am replacing those two terms, right? And the next thing is this same expression I am writing in different way. That's it. Here, because these two terms are in multiplication, right? So I can write as sine omega dt plus theta into cos theta. That is, this expression can be written like this since these two terms are in multiplication. That is, 2 into 3 is equal to 6. Similarly, 3 into 2 is equal to 6. Right? That makes no difference since it is a multiplication. So here I have written this term first and this term next. Similarly here, this term first and this term next. Right. Now, when you look at this expression, that is sin A cos B minus cos A sin B. So this is nothing but the formula of sin A minus B. So sin, this is in the place of A I am having this one, and in the place of B I am having theta. So sin A minus B. So A minus B. So here again plus theta and minus theta cancel each other. And finally here we will be having sin omega dt. Right. So we got differentiated, and finally the next step is we have to differentiate this equation we have done, and we have to make this equation equal to 0. So here just replace the value of t by Tp because we are calculating peak time. So this becomes P, and here also the equation becomes P, and this the value when differentiating, the value should be equal to 0. So here I am making this differentiated term equal to 0. Again, here we are having 1, 2, 3 terms I am having here. And finally, if any one term is equal to 0, this entire expression will be equal to 0, right? Because these 3 terms are in multiplication. As we all know, an exponential term can never be equal to 0. So this first term cannot be made equal to 0, right? Similarly, this second term also. So here I am moving to this third term, and I am going to equate this term to 0. So here I am equating this expression to 0. So omega d into Tp, I am writing this expression as pi. Sin pi is equal to 0. So when the value of sine will become 0, it is clear from the graph. This is your typical sine wave, that is 0 pi. Again, when you draw another wave, it will become 0 at 2 pi. Right. So this is our sine wave. So when the value of sine wave will be equal to 0, when it is at pi and 2 pi. So initially it will be 0. At 0 also it will be 0. So 0, pi and 2 pi. So now this equation will be, that is this term, I am equating this term equal to pi because here sin pi is equal to 0. What is the value of pi? Pi is nothing but omega d Tp, right? So omega d Tp is equal to pi. Why I am not equating it to 0? Because we cannot find an expression if we equate this term to 0. So I am moving to the second option as pi. So omega d Tp is equal to pi. So from this equation the value of Tp will be equal to pi by omega d. So as we all know, the value of omega d is omega n into root of 1 minus zeta square. So just replace this omega d by this equation, and finally we are getting an expression for peak time. So peak time is given by pi by omega n into root of 1 minus zeta square. That's all. The derivation gets over here. Hope you people understand. Thank you.